simple. Does electric field line gives accurate information or rough estimation on electric field, sir?
Very good. You can measure very precisely. If you calculate electric field lines by the so-called the conventional way, right, calculating the force, dividing it by test charge, whatever field you are getting, the same electric field expression you can definitely obtain through this. Okay. The appreciation of Gauss law comes through its simplicity. Okay, electric fields are basically vector, difficult to deal with, and there is an integral. On the right hand side you have only the scalar quantity, namely charge. So you know very well how to add a charge, correct? Quite simply you can do.
Good afternoon, sir.
Yes, good afternoon.
So my question is, can a DC device run through AC current?
No. What happened? DC current, the device depends upon the situation. The DC device going to operate only where you have the material or application where you need only the flow of charges in a particular direction. If you apply the AC, the component that was there inside the device is not going to operate. Then what happens? The device not going to work. Right. So most of the semiconductor device where you have to allow only the direct current, one directional current. You apply the two directional current, that particular integrated circuit we call as the IC, that will not going to function because it needs only one directional. If you apply the change in polarity there, then that device not going to work. It is going to just heat up. The energy going to stop there, the device is going to heat up, then the function of that device not going to happen.
Good afternoon, sir.
Yeah.
My question is about EM waves.
Yeah.
So when EM waves basically consist of an electromagnetic field that changes and that induces a magnetic field, and that even that the intensity of that even changes induces another wave and so on and so forth.
Yeah.
So my question about that is, could it be considered 100% efficient transfer of energy from one form to another in a medium? Because there's no power loss that's usually associated with converting energy from one form to another here.
See, 100% efficiency is an ideal condition. If you have 100% efficiency, you would have violated second law of thermodynamics. So the universe works around that, okay? So there is nothing called as 100% efficiency, you can have it. If you had 100%, see the basic idea is efficiency, we'll go to thermodynamics, I think, little bit deviate. Well, I'll answer your question. So efficiency is output power by input power, that's the basic idea of efficiency, okay?
If I use a battery to charge a capacitor and then remove the battery and replace another uncharged capacitor with it in parallel, will there be any change in the total energy of that system?
You have a capacitor, so you
charge
charge that completely, okay, fine, and then
And I connect an uncharged capacitor with that charged capacitor in parallel, will there be any change in the total energy of that capacitor?
the total energy should be same. Let's imagine that you don't have wire. What will happen?
Total energy of that system will be conserved.
Conserved, right? Yes. So the wire is an external this one, okay? So again, it is I square R and all these things will happen. But as such, the total energy, including the energy corresponding to the metal wire, what you connect, total energy should be same, right? But only thing is that the charges what you have in the capacitor 1 and charges which you might get in the capacitor 2 might be different. The total energy has to be conserved.